I'm David Bombal, and I want to welcome you to another Pikiti.com presentation. In this video, I'm going to explain and demonstrate the configuration of physical HP switches running OpenFlow and integrated with the HP VAN SDN Controller. We'll look at the configuration of both HP ProVision switches as well as HP Comware switches. We'll then look at the results. So I'd like to show you some show commands on the HP switches, as well as the output on the HP VAN SDN controller. This is an example of what the topology looks like on the HP controller. The topology consists of 2 Comware switches and 2 ProVision switches, each having a Windows machine connected to them. I'll show you the output of the OpenFlow flow tables on the HP controller, as well as on the HP switches. To configure OpenFlow on an HP ProVision switch, do the following. Type configure OpenFlow. That takes you to global OpenFlow configuration mode. Specify a controller that's going to manage the switch. In this case, the command controller ID 1 is specified. The range is from 1 to 128. That allows you to have multiple controllers managing separate instances on the switch. Specify the IP address of the controller. So in this case, IP address 192.168.56.7, referenced with controller ID 1, is going to manage instance VLAN 10 on the switch. It's a requirement that the VLAN used for communication to the controller from the HP ProVision switch be non-OpenFlow enabled. So this switch is communicating with this controller using this interface, VLAN 192, and OpenFlow is not enabled on VLAN 192. That is just a traditional routing and switching VLAN. In this example, a single instance is configured, instance VLAN 10. VLAN 10 here is just a name, so it doesn't have to match the VLAN number that the instance is associated to, but for consistency, I've kept it the same. So instance VLAN 10 has a member of VLAN 10. On HP ProVision switches, there is a 1-to-1 mapping between the instance and the VLAN number. In other words, when running what's called virtualization mode, which is what I'm demonstrating here, every VLAN has a separate OpenFlow instance enabled on it. The controller ID, once again, that's in control of this instance is 1. In other words, this controller is managing OpenFlow on this VLAN. The default version of OpenFlow enabled on HP ProVision switches is 1.0. In this case, I've specified that the switch use OpenFlow 1.3. There is an option to use the keyword only after the version number. In this case, I haven't specified only, which means that the switch will negotiate to the highest supported version that the controller supports. In other words, if the controller only supports OpenFlow version 1.0, the switch will use OpenFlow 1.0 with the controller. However, if the controller also supports 1.3, the OpenFlow communication between the switch and the controller will use OpenFlow 1.3 because that's the highest supported version on both the switch and the controller. On ProVision switches, you need to enable the OpenFlow instance, and then you need to exit back to global OpenFlow configuration and enable OpenFlow globally on the switch. So in other words, the instance is enabled as well as OpenFlow globally on the switch. This is the basic configuration of OpenFlow on an HP ProVision switch. To support OpenFlow 1.3, HP ProVision switches require a minimum of 15.14 version of firmware. This enables a single instance of OpenFlow on the ProVision switch. The VLAN that's now controlled by the controller is VLAN 10. Now this is an example of pure OpenFlow or pure SDN. The switch is not in control of this VLAN. The brain is in the controller. In other words, when traffic is received on VLAN 10, the switch is using what's called active mode, which means that the controller is in control of that VLAN. When traffic arrives on the switch, the traffic will be forwarded based on the flow entries in the OpenFlow pipeline. The HP VAN SDN controller will configure a default rule to forward all unknown traffic to the controller. HP Comware switches do not support OpenFlow 1.0, they support OpenFlow 1.3 and will negotiate to use OpenFlow 1.3 with the HP controller. To configure OpenFlow on a Comware switch, type System View, OpenFlow Instance and specify an instance number. A description could be specified. To associate a VLAN to the OpenFlow instance, use the classification command. Now, Comware switches allow you to associate multiple VLANs to a single OpenFlow instance. In this example, a single VLAN has been associated with instance 1, but you could associate VLAN 10, 20, and 30 as an example with instance 1. That is different to virtualization mode on a ProVision switch where there is a one-to-one mapping between VLAN and OpenFlow instance. ProVision switches do support what's called aggregate mode, where all VLANs are associated with a single OpenFlow instance except for the VLAN used for communication to the HP controller. On HP Comware switches, you explicitly associate either one or multiple VLANs to the OpenFlow instance. In a separate video, I'll show you how to map multiple OpenFlow VLANs to a single instance on HP Comware switches. In the next step, you need to specify which controller is used for this OpenFlow instance. In this case, we only have a single controller, referenced with this IP address. And similar to the configuration of multiple spanning tree on Comware switches, you need to activate the instance. If the activate instance command is not specified, the configuration will show in the running config of the switch, but won't be used. Please note that this command does not show in the running config or current config. If you type display current, you won't see activate instance in the configuration in a similar way to the configuration of multiple spanning tree, but the command is required to activate your configuration. So without further ado, let's look at the configuration of the physical switches in the lab and look at the flow tables on the switches. This is the output on the HP VAN SDN controller, showing that the switches have registered and that the controller has discovered the links between the switches and the hosts connected to the switches. These two switches are ProVision switches. So as an example, clicking on OpenFlow Monitor will allow me to view the registered switches in the topology. I'll start with this device ending in DPID 18.0, which is the device shown on the bottom left of this topology. Now on HP ProVision switches, the data path identifier or DPID is identified as follows. The most significant 16 bits is the VLAN number. In this example, OpenFlow has been enabled on VLAN 10. So the most significant 16 bits is set to 000A. These two devices are Comware switches. On Comware switches, the most significant 16 bits is set to the instance number, in this case instance 1, hence the number 0001 in hexadecimal. The least significant 48 bits of the DPID or data path identifier is the MAC address of the switch. So first 16 bits on ProVision is the VLAN number, on Comware is the instance number, and the remaining bits is the MAC address of the switch. This switch, as you can see, with this IP address ending in 103, has negotiated to use OpenFlow 130 with the HP controller. So on this switch, which is the ProVision switch, 3801, DPID ending in 1800, we have three interfaces displayed on the controller, 2, 7, and 4. Typing show VLAN 10 on the switch will allow me to see the interfaces that are tagged or untagged for that VLAN. So as an example, 1, 2, 4, 7, and 8 have been configured in VLAN 10, but only 2, 4, and 7 are currently up. and therefore show up in the diagram. Interface 1 and interface 8 are currently down. Typing the command show run pipe begin open will allow me to search for the OpenFlow configuration. So here's the output. Show run pipe begin open. OpenFlow has been configured globally on the switch. The controller ID, IP address, and controller VLAN have been specified. The instance name has been specified. The member VLAN has been specified. The controller in use is controller ID 1 with this IP address. Version of OpenFlow configured is 1.3. The instance is enabled, and OpenFlow is enabled globally on the switch. So, show OpenFlow instance VLAN 10. In the output here, we can see the data path identifier of the switch, which is this switch on the bottom left of the topology. The configured version of OpenFlow is 1.3, the negotiated version of OpenFlow is 1.3, instance name is 10, the instance has been enabled, the member VLAN list consists of VLAN 10. Once again, there's a one-to-one mapping between the instance and the VLANs on ProVision switches. It's currently up. Flows can be located in either hardware or software. The number of hardware flows and number of software flows are shown. For controller ID 1, the switch is currently connected to the controller and the status is active. Master and slave roles haven't been configured. There's only a single controller managing this switch at the moment. I could also look at the flows on the switch, and I will come back to this after showing you the controller output. But just note that there is a flow table with various entries in the flow table. So as an example, flow 1 is matching any kind of traffic. This is a hardware table, table 0, and the instruction is to send the traffic to table 100, which is another hardware table on the switch. The second ProVision switch has been configured with the same OpenFlow configuration. As the configuration is the same, I'll just show it briefly. Show VLAN 10 shows me that some ports are enabled for OpenFlow. In this case, port 1 is up, but no devices have been discovered on port 1. A host has been discovered on port 2 in the topology, and there are infrastructure links to other switches in the topology on port 7 and port 4. Show run pipe begin open shows the same configuration as the previous ProVision switch. This ProVision switch on the right has exactly the same configuration and has negotiated to use OpenFlow 1.3 with a controller. We can see that here. Both ProVision switches and both Comware switches are using OpenFlow 1.3 with the controller. Show OpenFlow instance VLAN 10. Notice the data path identifier is the same as the switch on the right-hand side of this topology. Negotiated version of OpenFlow 1.3, very similar output as the first ProVision switch. So now let's look at the configuration of the first Comware-based switch, which is in the top left part of this diagram. This is a 5900 series switch. I'll type system view, display current, pipe begin open. Notice a fairly basic configuration. OpenFlow instance is instance 1, hence the DPID starts with 0001. OpenFlow has been enabled on VLAN 10. It's communicating with the controller 192.168.56.7. Display OpenFlow instance 1. I can see here that VLAN 10 is associated with instance 1. The instance is currently active. The ports associated with the instance are listed here. The data path identifier is shown here. And notice that's the DPID on the left-hand side of this topology. Same DPID. OpenFlow is enabled on these ports. but some of the ports are currently down. Notice, however, 2, 4, and 7, these interfaces are listed in the output. The switch is communicating with the controller on this IP address and this port number. So let's have a look at the configuration of interface 2. This is an access port in VLAN 10. Interface gig 104. Display this. This port is a trunk. So port 4 connecting this Comware switch to the second Comware switch is configured as a trunk permitting VLAN 1, 10, and 20 across the link. The native VLAN or port VLAN identifier or untagged VLAN on this port is VLAN 10, the OpenFlow VLAN. Interface gig 107, display this. Same kind of configuration. Now on the provision side, port 7 is configured as a tagged port. So on 3801, this switch here, show VLAN port 7, shows me that VLAN 1 is configured, 10 and 20 are configured. If we look at the details, you can see that VLAN 10 is the untagged VLAN as specified on the Comware side. So both sides are using VLAN 10 as the untagged VLAN. That is the OpenFlow enabled VLAN. Now a similar configuration exists on the second Comware switch, and for the sake of time I won't show you that config. Let's look at the OpenFlow tables and details of the switches. So firstly, I'll change the view of the nodes to MAC address. I have set the MAC addresses of these PCs, Windows PCs in this example, to these simple to read MAC addresses 2, 3, 5, and 6. So on the 3801 series switch, this switch over here, DPID ending in 1800, a device with MAC address 5 is connected on port 2. So DPID ending in 1800, go to OpenFlow Monitor, which is this menu option. Select the switch. I can look at summary. I can see here's an example that an HP switch has negotiated with the controller using this IP address, negotiated version of OpenFlow is 130. The number of tables supported in the pipeline is 3. DPID of the switch is listed and the capabilities of the switch is listed. Let's look at the output of the first Comware switch, DPID ending in 3B. That's this first switch over here. Look at the summary. We can see this is an HP switch, hardware version, software version, serial number, data path identifier, IP address, negotiated version of OpenFlow, number of tables supported, number of buffers supported are listed here. In a separate video, I'll explain the tables and the buffers. This video is already getting quite long, so I'll defer that to a separate video. Capabilities are shown as well. So looking at the ports of the provision switch, notice they're listed here. And if we look at the output on the switch, so show VLAN 10, notice we can see similar information. Ports that are down are listed, as well as ports that are up. The hardware MAC addresses are listed, the port name and port IDs are listed. The speeds of the interfaces are listed as well. This interface, local, is the local management interface of the switch. When sending traffic from the OpenFlow pipeline to the management interface of the switch, traffic would be directed to this port number. On the Comware switch, looking at ports, there's a list of ports as seen on the HP controller, and if we display that on the switch, so display VLAN 10, we can see tagged ports 5 and 8, untagged ports 2, 4, 7, and 9. That kind of information is displayed here, as well as notice the port IDs are listed as simple numbers, but the port names are listed giving the exact names of the switch ports. such as gigabit 102. VLAN 10 is also listed, as well as the local management port of the switch. So once again, host with MAC address 5 is connected on port 2 of the 3800 series switch, DPID ending in 18.0, as we can see at the top here. And that's shown here. Let's look at flows. Notice as an example that traffic with a source MAC address ending in 05 received on port 2 with a destination of 2 will be sent out of port 7. Looking at our topology, traffic from this MAC address coming in on port 2 will be sent out of port 7 to get to MAC address 2. So that's correct as per our topology. This is an example of the OpenFlow table as seen on the controller. This is an OpenFlow entry stored in the hardware table of the provision switch. In this case, it's stored in hardware table 100. The flow entry has a priority of 29999. The number of packets matching is listed here. The bytes are not shown as the entry is in hardware on the switch. Match entry is shown, and the instruction is shown here to send the traffic out of port 7. On the Comware switch, ending in 3B, let's look at the flows. We can see as an example that traffic with source MAC address 2, destination MAC address 3, received on port 2 is going to go out of port 4. In other words, traffic from this MAC address received on this port going to this MAC address 3 is going to be sent out of port 4. That's correct as per our topology. We can actually see that by clicking on a host specifying a source, clicking on another host specifying a destination, and notice the path is displayed in the topology. Once again, let's make this guy the source, this guy the destination. Notice the traffic is taking that path, or going to host 3, it's going to take that path through the topology. So, as you can see here, the flow tables of the switches are listed on the controller. Please note that there's a different flow entry for ARP versus IP version 4, as they are different ether types. On the provision switch, we could type show OpenFlow instance VLAN 10 flows, and we'll be able to view the flow table of the switch. So scrolling down to flow entry 4, flow entry 4, incoming port is 4 as shown on the controller. I'll move this around to give us some more space. So port 4, incoming port is port 4. Source MAC is 6. Destination MAC is 5. Traffic type, IP version 4. No other values are matched on. We have wildcarded other values, such as IP DSCP and so forth. The priority is 2,999. The duration of the flow entry is shown, and if I click on the controller, I'll be able to see the duration of the flow, as well as the idle timeout and hard timeout. Now, because of the delay between me showing you the output on the controller and the switch, the duration here is longer than what was shown on the controller. I would simply refresh the controller page to see updated packet count, updated duration. Here's the idle timeout set to 60 seconds, and here's the hard timeout as per the controller, 0 seconds. In other words, a hard timeout hasn't been specified. Idle timeout is 60 seconds. If no traffic matches this flow entry for the duration of 60 seconds, the flow entry will be removed. Instruction is to send the traffic out of port 2, and you can see that on the controller. The hardware table that this flow entry has been put into is table 100. So that's an example on a ProVision switch of a flow entry. Let's have a look on a Comware switch. So display OpenFlow instance 1 flows or flow table. So in this example, we have an input interface of gigabit 102. That's this first entry. Destination MAC address is 3. Source MAC address is 2. Ether type is ARP. Notice this is a different entry to the second entry in the controller. That's IP version 4. Scrolling down, we can see that the instruction is to output the traffic out of gigabit 104. So that's an example of a flow entry on the controller and on a Comware switch. Scrolling up here, we can see things such as the hard timeout, idle timeout, packet count. In other words, similar to what we saw on a ProVision switch. Now the counters on the controller are updated when you refresh the page. That sends an OpenFlow message to the switch and asks the switch to send back updated statistics. So as you can see here, packet count is very similar. There was a slight delay between refreshing the web page and showing the output on the switch. Clicking on this entry, I can also see the idle timeout, the duration in seconds, and so forth. So very detailed information can be gleaned from the controller about flow entries on switches, the flows that traffic takes, the switches in the topology, the hosts in the topology, and so forth. Because of the length of this video, I'm going to end at this point. I will show you other options in separate videos. In this video, I showed you the configuration of HP physical switches running OpenFlow, and I showed you both ProVision and Comware switch configurations. I showed you the results on the HP controller as well as on the switches. We looked at flow tables, and I showed you those flow tables on both the controller and the switches. I'm David Bombal, and I want to thank you for watching this video. For more details about OpenFlow, SDN, the HP VAN SDN Controller, HP switches, and other related topics, please visit pakiti.com.